Hello, my name is Josie and I'm doing test 2 for physics. And I'm going to do question 2, which says, staying on the NASCAR theme, using the coefficient of static friction above, which was 0.6, what is the max speed for a car going around a 250 meter radius curve on a flat track? Maximum speed without sliding. Okay, so what we're trying to find is the maximum speed of the car without sliding. So first I'm going to write down the information I know. So using the coefficient of static friction above 0.6. So U equals 0.6 and U like coefficient of static friction. What is the maximum speed for a car going around a 250 meter radius? So we're finding V equals question mark going around a 250 meter radius on a flat track. So 250 meters is R equals 250 meters. Okay, now I'm gonna look for an equation, and the first page is from last test. So okay, so we have the centripetal acceleration equation, which is a circle. And we have the circular motion, which is a circle. And the circular motion equation is by the static friction equations. So I'm going to use the circular motion equation and see. So F equals m v squared over r. So we're v squared r and F, but we would then have to get rid of mass if this equation will work. And we don't have coefficient of static friction, US, in this, which is Fs max equals USFN. Okay, so what I'm going to do is combine Fs max equation and the circular motion equation. So I'm going to solve the circular motion equation for velocity since that's what we were trying to find. Well, I'm going to, yeah. So F equals mv squared over r turns into Fr equals mv squared turns into v squared equals Fr over mass. Okay, so we don't know mass. Okay, actually, yeah. I'm going to then put in Fs max for F. So v squared equals equals Fs max times r over m. But we know that Fs max equals v squared equals USFN v over m. Okay, so Fn is equal to Fn is equal to Fg because it's no up and down motion because the track is flat. So there's no vertical motion, so Fn equals Fg. And then on the sheet, FG equals MG. That's how we're going to get rid of M. Yeah, M. So now go down. So now we have V squared equals US FG R. Sorry, I just can't read my handwriting. R over M goes into V squared equals US, and then FG equals MG R over M. M's can cancel out, and we're left with V squared equals US, coefficient of static friction, gravity, radius. There's my equation. So what I did to get that was I took the circular motion equation, solved it for velocity or speed, and then plugged in Fs max for F, which used my coefficient of static friction, and Fn was then equal to Fg because there's no vertical movement since it's a circular track, and Fn equals Fg. And then Fg equals mass times gravity, and then I was able to get rid of mass. Now I'm going to solve for this equation, or just plug in the numbers. So V squared equals US, which was 0.6, times 9.8 meters per second squared. R, 250 meters. Wait, I have to put seconds on the bottom. 9.8 meters over second squared. And then put that. 0.6 times 9.8 times 250. So V squared equals 1470 meters squared per seconds squared. V equals 38.34 meters per second. Oh my gosh. Okay. And that's sig fig. So 0.6 is 1 and 250. Okay. So it's V equals 38 meters per second because 250 is 2 sig figs because there's no period at the end of the zero. So I got 38 meters per second. So now, does that make sense? So staying on a NASCAR theme, using the coefficient of static friction above, which is 0.6, what is the max speed a car could go around a 250 meter radius curve? So 250 meters curve, 38 meters per second. Yeah, that seems, well, let's see. Okay. So we have 250 meter radius curve. Okay, so this is the curve. Here's the radius is 250 meters, so pi r squared pi 250. So it's a 600. I don't know how many meters are in a mile. It's a 616,850 meter track. Is the circumference of the track. 38 meters per second. If a meter is like this big and you do 38 of those per second, that's pretty fast, but it's also a big track. So do we think that is reasonable? Yeah, that seems reasonable to me. Because circumference equals pi r squared, I think. So yeah, going 38 of those meters per second, because it's not a super track, that seems reasonable. So I think our answer of 38 meters per second is reasonable, and the equations we used were the circular motion equation, static friction equation, and the gravity equation. Here's my work. Thank you.